Take a look at the very first part of our word list for the final lab practical in 202. The very first thing we're going to talk about is a continuation of the stomach through the pyloric sphincter. Now here in this model that we see, it doesn't really show a very good pyloric sphincter, but we know this is the lesser and the greater curvature. This is the pyloric region, which allows you to bring chyme directly then into the duodenum. The duodenum contains openings for both the major and the minor pancreatic ducts. And on this model, you'll see that the major pancreatic duct, as well as a common bile duct, fuses together. Right? As it fuses together, it empties into an ampulla, an opening that we call the ampulla vater, which will probably be better on a picture. Right? Then the sphincter of Oddi is a little kind of constriction of smooth muscle, which allows us to drain the ampulla vater and bring bile and pancreatic juices into the duodenum. Now, as I put the little pointer here, you'll also notice that the duodenum contains all these real thick ridges. The ridges are going to be found throughout the rest of the small intestine. The ridges are called the plica circularis. And if you remember, the plica circularis is going to be very important because the plica circularis is going to be allowing us to kind of break down some of that thicker chyme particle, break it down into a soupy, right, not so thick, so then the enzymes that we just released can work its way all the way through. The duodenum then is going to turn into the ileum. Let me phrase that. It's going to turn into jejunum and then the ileum. Now, the easiest way to remember which one is which is by first looking at where it ends. Right? The ileum always ends at the large intestine. As it ends in the large intestine, it ends in the start of the large intestine right here. Right, that area is called the cecum. So we have the ileocecal junction right here, and then the canal, which is an opening between the ileum and the cecum, and then you see the smooth muscle right here that forms the ileocecal sphincter or valve. Right, so anything that is proximal to that is the ileum. So here you can see that everything in light brown will be the ileum. So number 13, letter A, that's all ileum, where everything in this darker tan will be there for the jejunum. Right? Now, as we hit the ileum right here, we're going to see that, right, by the time food enters the cecum, it will be turned into waste. So the start of our large intestine is called the cecum, and if you follow the cecum all the way down, then you see this kind of small worm-like organ that we see on this model as well, right? The small worm-like organ is called the vermiform appendix or just appendix, right? The appendix then is going to be where it's a small pouch. It doesn't drain into anything. So sometimes if you have an infection here, you can't have the drainage of that fluid or those cells out. Now, most of the time, food matter waste moves up through these series of areas that we call the large intestine. Now, the book and most medical journals talk about the colon and the large intestine being identical, and they're used interchangeably. Right? What we're going to see in the colon is that you see an ascending, transverse, descending, right, colon regions. On the ascending region, you're going to see that at the point where it kind of turns into transverse, you have a bend. The bend is called the hepatic flexure because it's next to the right very large organ on the right side of your upper abdomen. The organ is your liver. Right? As we move across the transverse colon, then you see another bend going downwards. This is right next to the spleen. This is the splenic flexure. Right? Now, the large intestines, the descending colon continues down. As it continues down, it turns into the sigmoid colon. But on this board model, we really don't see it well. On this model, we see it much better. The sigmoid colon forms kind of a weird S shape, right? So here's our weird S shape right here that we see. This is a sigmoid colon. The sigmoid colon moves the waste from anterior part of your abdomen backwards and then down into the rectum, right? So here's a sigmoid colon right here, S shape aspect, and then the sigmoid colon eventually allows you to bring that waste into the rectum. So this whole thing is your rectum, right? And the anal canal is the opening found in the rectum. The rectum also contains all these ridges that are part of your hemorrhoidal veins. right? The rectum also contains a very large external anal sphincter, which I will show you on a different model, probably on a different day. Now, besides the rectum and the actual kind of materials found in the rectum and the anal canal, throughout the small intestines, we saw two layers of smooth muscle, inner circular, outer longitudinal. Right? It looks like sausages because both layers are very complete. In the large intestine, the layers are not complete. What we're going to see is you have a complete circular layer that are now going to be formed into what looks like little pouches. These pouches of inner circular muscle are called haustra. So each of these are haustra. Right? All of these kind of pouches, those are all haustra, all the way through. Now, the outer layer is not complete. The outer layer of muscle is formed into strips. These strips that we see are called the tinea coli. So you see the tinea over here, all the way around. Right? The tinea coli allows us to form those haustra. So then you have all of the materials going through it. You can have waste going from segment to segment to segment. Now, what we do see on this model right here that makes it slightly different is you see the fatty drape. The fatty drape covering both the small and the large intestine right here is called the greater omentum. It's a fatty apron that covers it, and usually if you've never had abdominal surgery of any kind, the fatty drape will be a complete covering. If you have had abdominal surgery, this fatty drape will be kind of obliterated. Now the lesser omentum is going to be found between the stomach and the abdominal wall, so it'd be probably in the form of a picture. Now the mesentery is the connective tissue that holds, that holds your small and large intestine in place. So what we see here and here are the mesentery. Not only does it hold the small and large intestines in place, it also protects the blood vessels to prevent it from kind of wrapping around itself. So you see the superior mesenteric artery coming down, the inferior mesenteric artery going to the left. These are your mesenteric arcades. The arcades are the actual anastomoses between different arteries, and it allows for alternative way to bring blood flow in case one region has an infarct or a clot. Now, the mesentery is that connective tissue. Again, keeping the small and large intestines in place, protecting the blood vessels so then it cannot kind of wrap around itself. Now, in this picture, you can actually see the common bile duct coming down, and you can see how it kind of drains into the duodenum. Now, last model right here is an actual microstructure of the small intestine. The small intestine contains the ridges that we call the plica circularis.